Yes, sir.
So last class we solved one example about how to locate that instantaneous center. Today we'll I'm giving you this as an assignment. Okay, this is the question. Suppose it is not example. Okay, it is assignment problem. Module 2 ra মানে assignment 2 ra first question. This will be question 1. Okay, so here a mechanism is being given to you. Let me draw it. Let's say we have this fixed support. Here we have another fixed support. Then we have a link here, and this link is connected with this, and from here another links go and is connected with this slider. The slider slides along with this fixed guide. Okay, so let us give nomenclature O A, then you have B here, C, D. Then let us name the links here. This fixed part is suppose link 1, this one is link 2, this is link 3, this one is 4. Okay, this fixed part is again it is 1. Okay, every fixed part will take as one link. Then this is 5, fifth link. Okay, this one is sixth link connected to the first. This is also 1. Okay, now the dimensions are given to you. OA is given OA is given 200 mm. AB is given 1.5 meter. BC is given 600 mm. CD is 500 mm. Then BE. Okay, this point is E. Okay, this point is E. So BE is 400 mm. Question is you have to locate all the eye centers. Okay, and if crank OA rotates uniformly at 120 rpm clockwise in clockwise direction, means in this fashion, find velocity of B, C, and D, and angular velocity of the links AB, BC, and CD. Okay, so this is the assignment question. So I'll help you in finding out the instantaneous centers. Suppose so from here directly we can find out. Okay, let's see here we have link 1 is there and link 2. So this eye center will be I12. Okay, this will be I23. Okay, and What about this? It will be I will tell 3
I
4.
3 4.
Yes, this will be I 4 5, and this I center will be I 5 6. Okay. Now these are the fixed or permanent eye centers we obtained. Now what about those neither fixed nor permanent eye centers? Okay, how to obtain? So first is you see here, uh, it is a slider. It is link 6 and connected with link 1. So as it is a sliding velocity is there, so the eye center will be at infinite. We all know. So it will be I 1 6 at infinity. Okay, I 1 6 at infinite position. Then just a second. Okay, then we have mm, here if you extend this link 5 is along with and extend this line. So this will be equal to your I 1 5. Okay, and here we'll have 4 6. Now you extend this line. Okay, and join this with this line. Okay, this line also. Let me erase here. So let's say they meet somewhere here. So it will be equal to I 1 3. Okay, because 3 and this 1 is coming across this point. Easy to remember. So it will be I 1 3. Now similarly here also, if you extend, this is also can be named as I16 at infinite. Okay, and you have 4 and 6, 4 and 6, no, link 4 6. So this much. Now these are the eye centers. Now how to find the number of eye centers? Here eye center location, eye center location. So number of eye centers will be how many? Number of eye centers. So n will be equal to n into n minus 1 by 2. Okay. So you'll have 5, 6. So 6 into 5 by 2. It will be total 15 number of eye centers are there. Okay. Then you prepare the table. Okay. So tabular data. So you'll have link, then eye centers, then the links are, as you can see, 1 2 3 4 5 and 6. So here we'll have 1 2 1 3 1 4 1 5 and 1 6. Here we'll have 2 3 24, 25, 26, 34, 35, 36, 45 and 46, and here we'll have 5, 6. So these are the 15 eye centers. Okay, screen is visible to all of you.
Yes,
Yes,
sir.
sir.
So from these eye centers, which are fixed and permanent, you mark them. So 1, 2 and 1, 4. Okay, then here 2, 3, 3, 4, 4, 5 and 5, 6. Rest are neither fixed nor permanent type. So in this fashion you proceed, and this diagram you have to draw to get the result. You have to draw this diagram as per scale. Okay, let's say OAS is given 200 mm and this AB is given 1.5 meter. So you choose your scale accordingly so that this entire diagram will be fitted in your copy. So you choose the diagram scale as per your requirement. Then you will find out these eye centers and the velocity of point B, C, D and the angular velocity of link AB, BC and CD. Okay, this is your assignment. So you try to solve it. Okay. Further, we'll proceed to another method, which is your relative velocity method. Okay, relative velocity method. So, relative velocity method. So, here you can see the velocity of different point in a mechanism. Velocity of different points in a mechanism can also be determined determined using relative velocity method. Using relative velocity method. Okay. Now, a relative velocity of two bodies moving in a straight line. We'll see. Let's say relative velocity of two bodies moving in straight line. Uh, if say two bodies, if two bodies A and B are are moving along parallel parallel lines in in same direction with absolute velocity absolute velocity, let's say VA and BB. Okay, let's say this is body A moving with the absolute velocity va. This one is body B moving with absolute velocity b. And here condition is BA is greater than BB, suppose. Now a relative velocity, then you can say then relative velocity of A with respect to B can be termed as BAB, B subscript AB, okay, which is basically the vector difference of BA and BB, and it can be represented as BA vector minus BB vector. Okay, it may be graphically represented as follows. You can say it may be graphically represented as follows. Let's say we have this line O. This is point A, and I'll take this as point B. Okay, so graphically, this is our VA, absolute velocity of body A. Okay, you can say, and this is VB, absolute velocity of body B. Then this part, the vector difference is BAB. If you go in this direction, okay, remember this direction is very important, and if you are moving the alternative way, it will be termed as velocity of B with respect to A, and its direction will be towards left. Clear? So this BA
Yes, sir.
is equal to basically OA bar minus OB bar. Similarly, relative velocity of B. So we can write similarly relative velocity of body B with respect to A can be represented as V subscript BA. Okay, so it will be expressed as VB minus BA. Okay, and it is A to B, that is OB minus of OA. Okay, so this is the basic difference of representation graphically. Now, if body B is moving, if body B is moving in an inclined direction, the relative velocity of body A with respect to B may be obtained using parallelogram law. Okay, law of parallelogram. Law of parallelogram of velocity or triangle law of velocity. This I think you all know. So I'm going to explain it. But we can represent this as, suppose body A is having a velocity. This is body A having velocity, absolute velocity VA, and this is body B, which is having an inclined velocity in the same direction, which is VB. So we'll represent this using, we'll find out the relative velocity using parallelogram law. So we'll take one origin point. Let's say this is origin O. Then we'll draw. We know the magnitude and direction of both the velocities. Okay, so you draw as per scale. Suppose this is represented as our BA. Okay, suppose BA is 10 meter per second. I will choose a scale that once mm equal to 1 meter. So it will be my 10 mm. Likewise, as per scale. Okay, so this is OA, and which is parallel to VA direction. Okay, now from the same origin, again you draw as per scale BB. Suppose this is my BB. Okay, so this point is our B. Now you join this. Okay, so this will be the relative velocity of A with respect to B. See the direction here. Okay, as the arrow mark is going towards A, that's why it is the relative velocity of A with respect to B. And if you want the alternate one, the direction will be like this. It will be the relative velocity of B with respect to A. Remember this notation. Okay, so this is a closed parallelogram. If you close this, it will be a parallelogram. I think I'm clear to all of you.
Yes,
So your procedure is, take any fixed point, any fixed point O, and vector draw vector OA representing this velocity, absolute velocity of body A in magnitude and direction. In magnitude and direction to a suitable scale. With a suitable scale you have to draw. Okay. Similarly, now draw OB. Just a second. So now draw OB representing the absolute velocity of body B, it is VB, in magnitude and direction. Okay, to the same scale. You'll take the same scale, huh? To the same scale. Then join Then join this BA, which which represents relative velocity relative velocity of A and B. Okay. Now come to one important aspect, that is motion of a link. Motion of a link. How to find motion of a link? Let us consider that let's say we have one link of this arbitrary shape. We'll take 2 points on it in the axial direction. Let's say this is point A, this is point B, okay, and the link is having an angular displacement in this way. Let's say it is omega. Okay, now this line will represent velocity of point B with respect to A. B subscript BA. Clear? Now we'll choose another point, let's say C. So consider any 2 points, 2 points A and B on a rigid link, on a rigid link AB, and let point B, let point B moves relative to A, okay, in clockwise direction as shown, in clockwise direction. Okay, as the distance between A and B, as the distance between A and B always remain constant, always remain constant. Therefore, therefore, there can be no, there can be no relative motion, no relative motion between A and B along AB. Along AB, no relative velocity is possible between point A and B because this distance AB is always fixed. Okay, and this BA, that is relative velocity of point B with respect to point A, is it should be or it must be perpendicular to AB. Now am I clear why we represent this velocity perpendicular to the link length? Because the link length is fixed, and if you take any two fixed point on the link, their distance will be also fixed, so there cannot be a relative motion between those 2 points, so we can represent the relative velocity perpendicular to the line. Okay, so for this reason the relative velocity relative velocity of B with respect to A is is represented by a vector, you can say AB, okay, and is perpendicular to line AB. Remember, huh? Now let this omega is the angular velocity of link AB about point A, point A. Now this VBA, that is the relative velocity of point B with respect to point A, will be equal to this angular velocity omega multiply with the link length omega dot AB. Okay, and it is represented as AB dash. Let's say this is equation 1. Okay. Similarly, if you take any other point, similarly velocity of point C, any other point C on AB, on this line AB with respect to point A, okay, will be represented as VCA, and it will be equal to omega dot AC, okay, which is equal to small AC bar. This is equation 2. So in this way we can represent the velocity of any point on a link. So from both these equations, from equation 1 and 2, we have BCA divided by BBA is equal to AC by AB, which is omega AC divided by omega AB, or you can say it is equal to AC by AB. Okay, so this is the relation, or in short, VCA by VBA is equal to AC by AB. You remember this relation. Okay, now velocity of a point on a link by relative velocity method. How to find out? Let's say we have a link, we take 2 points on it. Okay, this is point A, this is point B. Okay, now let's say the absolute velocity of B is BB, and the relative velocity with respect to A must be normal to this line AB. So it is VBA and it should be normal, and the absolute velocity of point A is suppose VA. Okay. Now You can write here. Consider any 2 points. Consider any 2 points A and B on a link the absolute velocity BA is at point A and is known in magnitude and direction. We know both its magnitude and direction. Okay. Now the absolute velocity of point B is known by its direction only. We don't know the magnitude, by direction only. Okay. Now the velocity of B may be determined by drawing the velocity diagram as per scale. How to draw? Now let me draw this again. So this is our link. This is point A and this is point B. We know the magnitude and direction of point A, which is BA, and we know only the direction of point B, velocity, and this will be obviously normal to line AB because it is BPA, relative velocity of B with respect to A, and this is any other point C. Now the to draw. Now first step is I choose one origin. Okay, origin O. From origin O I draw a line which is parallel to BA and as per the scale to its magnitude. So we'll find this point A. Right. Now from point A I will draw a line perpendicular to this link AB. I will draw a line which is first one is not correct. Okay. So I will draw a line perpendicular to AB. This is my line. Now from point O I will draw a line which is parallel to your BB. Okay, so both these points will intersect here and this is my B point. Okay, so from A to B, this portion will give me BBA. Clear now?
Yes.
Okay. First step, you choose one origin, then draw a line parallel to BA with some scale. You will find this point A. From point A, you draw a line perpendicular to the link AB. Okay, and from the origin you draw a line parallel to the VB. So both line will intersect at point B. So this will give you the relative velocity of B with respect to A. Okay, and also from here, if you measure this line OB as per the scale, you will find the magnitude of BB. Direction was earlier known to us, now you will find the magnitude. And if you measure this line AB, we will find out the relative velocity of point B with respect to A. Okay, so let us note down the steps here. So first, take some convenient point O as origin. Okay, second step, through through point O through point O, draw OA draw OA parallel and equal to BA to some suitable scale to some suitable scale. Someone has switched on the audio. Please switch up your audio. Okay, 3. Then through point A, draw a line perpendicular to AB, okay, which represents VBA, relative velocity of B with respect to A. Okay. Then fourth step, through this point O, okay, draw a line parallel to VB, okay, intersecting the line of VBA at point B. Okay. Now next step is measure OB, okay, which gives the required velocity of point B, that is your VB. Suppose this line is coming as let's say 5 centimeter, and we choose 1 centimeter is equal to 1 meter per second. So the VB will be equal to 5 meter per second. Okay, likewise, okay, as per scale. Now sixth step is absolute velocity of any point C, okay, on AB may be determined by dividing vector by dividing vector AB at C at C in the same ratio in the same ratio as capital C. Okay, capital C. In other words, you can say that AC by AB is equal to capital AC by capital AB. Okay, in other words, you can say now join this OC, which gives the absolute velocity of point C, that is your B subscript C. So how to get BC here? You choose any point, a point small c on this line AB, okay, such that your small SC by AB is equal to capital SC by AB. Okay, means suppose capital AB is, let's say, 200 mm here, and capital AC is suppose 100. Okay, so now this small AB is suppose 5 centimeter as per scale. So you'll choose this point C at 2.5 centimeter because it is exactly half here. So you choose exactly half point here also up to the scale. Got me? Now you join this line OC to find out the absolute velocity of point C, which is BC. Clear now? Am I clear to all of you?
Yes, sir.
Okay. So ଆଜି ଏତିକି ଥାଉ. Next we'll start with velocity and slider crank mechanism.